Welcome to 7.EE.4 Goal 2 for video number 3, and this is video number 3. Your first video was writing inequalities and determining truth. Your second one was graphing inequalities and then also writing equations based on graphs you created. This particular video deals with addition and subtraction of inequalities. Materials that you need for this particular video are your missing, so please get that. If you need to, pause this video right now. As well, you need to label the page Inequalities Notes. So Inequalities Notes. And from now on, you're just going to be using your missing as sort of a notes page. If you want to, for this particular missing page, if you wanted to, you could create yourself a 3-flapped foldable. So you would essentially take a piece of paper, you'd fold it in half, and then you'd cut 3 flaps. So you'd cut 2 solid pieces out of that, so you would have 3 flaps. Your top flap is what we would be working on for today. Let's go on to our concept. Our concept today, let's first start, and I just drew a huge line on here. Our first concept is this. Inequalities. We have our first actual problem right here. We have x plus 5 is greater than 12. And the way we can solve this is actually kind of easy. When it comes to inequalities, it's helpful to think of this middle inequality, this greater than sign, as just an equals, or just ignore it for right now, but we are going to just treat it just like it was an equation, okay? So our first step would be for this is we could just simply subtract 5 from both sides, okay? Do not get afraid of that inequality sign. It's just going to remain there and it's going to look exactly like it does. So if we added something to a number x, we could then also subtract it. This operation undoes the other operation. So 12 minus 5 is 7. So our answer to this particular inequality is x is greater than 7. If we wanted to check this inequality, we could actually pick a number that's greater than 7. We could pick 8. So 8 plus 5, is that greater than 12? Yep, 13 is greater than 12, so we have solved that inequality. Let's practice a couple more, and let's really get this under our belt. Our next inequality, y plus 10 is less than 3. So looking at this, let's ignore that inequality. Let's not even think about it being there. And let's actually just say, well, if this were just an equation, what would we do to figure out what y is? Well, we could subtract 10 from both sides. And from there, we get simply y is less than. Once again, we're just copying that inequality down. 3 minus 10 is negative 7. So y is less than negative 7. So let's check our work. If y is less than negative 7, then negative 8 would work for this situation. Let's check. Negative 8 plus 10, is that less than 3? Negative 8 plus 10, is that less than 3? Negative 8 plus 10 is a positive 2, and yes, that's less than 3. Awesome. So we solved our inequality. Let's try another one. X plus 7 is greater than or equal to 10. So once again, we're going to sort of ignore this inequality. We're going to ignore that it's there. We just know that that is our balance point. So what we could do is subtract 7 from both sides, follow the same rules we always do for just equations, and figure out if something is adding 7, we could subtract 7. So if we do 10 minus 7, we end up with 3. So x is greater than or equal to 3. That means if I were to put 3 in for x up here, we would have a true statement. So 3 plus 7, is that greater than or equal to 10? Yes, it is. 10 is greater than or equal to 10. 10 is equal to 10. And then let's also check to see if the greater than also works. So we could say maybe 4. 4 is greater than 3, so we could say 4 plus 7. Is that greater than or equal to 10? Yep. 11 is greater than or equal to 10, so that also works. So here is our answer. X is greater than or equal to 3. All right, so for our missing page, let's now put this idea into a rule. And so let's actually go over to our missing page. Let's understand what we're doing. So if you wanted to, for your top flap, so if you had that 3 flap foldable, you would put this here in this top flap, and you would write for addition and subtraction. You could write that on the outside of your foldable, and then on the inside you could say, when you add or subtract the same number from each side of, that should say an inequality. It seems like everybody's going to ask me for a Mike and Ike now. Of an inequality, the inequality remains true. So essentially, if we add or subtract the same number from each side of an inequality, the inequality remains true. Let's do also these practice problems within your missing. Y plus 3 is greater than 11, so we could subtract 3 from both sides, and we'd end up with y is greater than 8. So any number greater than 8 would make this inequality true. Our next one, h minus a half, 1 and a half is less than 5, plus 1 and a half, that undoes, that's the inverse operation of subtracting 1 and a half, plus 1 and a half. H is less than or equal to 6 and a half. Awesome. So that should all be in your flap of your missing. Now, if you didn't want to make a 3 flap foldable, this information right here just needs to be in there. Let's practice 3 more problems and then we're done. Okay? 3 more problems. Here we go. Here's our 3 more problems. And I would suggest also putting this work in your missing. So our first one is 3 is less than or equal to b minus 1 1/3. So this is a tricky one. We have a fraction in there. So I'm actually going to turn this fraction right now into a mixed number, or an improper fraction. So we have 4/3. And I'm also going to write this 3 as something based on thirds. So I know this is really 3 over 1. And if I were to multiply the top by 3 and the bottom by 3, essentially keeping the proportionality of it, I'd end up with 9 over 1. So I can rewrite this inequality as 9 over 3. Whoops, I didn't keep the proportionality. 9 over 3. 9 over 3 is less than or equal to b minus 4/3. So let's think. What is the inverse operation of subtracting 4/3? Well, it's adding 4/3. So let's add 4/3 to both sides of our equation. And I'm just going to write my big, huge line down there so that way I can kind of ignore my inequality. And what we end up getting from all of this is 9/3 plus 4/3. That gets us 13/3, and that is less than or equal to b. 13/3. So if we wanted to, we could rewrite that as an improper fraction, or a mixed number, and that's 4 1/3. So essentially anything greater than this 4 1/3 or equal to 4 1/3 will work for b. So if we were to try, let's say 5, what if b equaled 5? 5 is greater than 4 1/3. So if we put that in for b, 3 is less than or equal to 5 minus 1 1/3. So let's see if that works out. 3 is less than or equal to 5 1/3. We could get 5 minus 1 is 4. And if we took 1/3 away from 4, we get 3 2/3. So is 3 less than or equal to 3 2/3? Yep, spot on. Awesome. Let's do a couple more problems, and let's figure out the last couple. So we have 3 is greater than or equal to g plus 7. First step, let's ignore that inequality and let's pretend that it's just an equality. So let's pretend it's a normal equation. And what we can do is now focus on that g plus 7. How do I undo that plus 7? I could subtract 7. That is our inverse operation. So 3 minus 7 is 4, negative 4. Ooh, goodness. And that is greater than or equal to g. So g has to be a number less than or equal to negative 4. Let's try one. Less than or equal to negative 4, let's try negative 5. So if I have 3 is less than or equal to negative 5 plus 7, negative 5 plus 7, 3 is less than or equal to 2. 5 plus 7 equals, or negative 5 plus 7 equals 2. So 3 is greater than or equal to 2. Yep, that works. One less problem, and then we're done. And I suggest pausing the video right now and trying this problem on your own. Remember, you need to find common denominators because we see a fraction here. And then after that, I think you can figure it out. So pause it right now. All right, so now that you have solved the problem, hopefully you paused the video and actually did this. Let's solve it ourselves. So our line down the inequality to just sort of keep that out of our mind. What's going to undo that 5/7? Well, we could subtract 5/7 from both sides. Subtract 5/7. So here we got b is greater than 2 minus 5/7. Let's think about what is 2 equal in sevenths. We could write 2 over 1, and we now need to multiply by 7. Multiply by 7, so we get 14 over 7. So 14 sevenths minus 5/7 equals a grand total. 14 minus 5 is 9/7. So b is greater than 9/7. All right, so let's think. What could be greater than 9/7 to make this all work? Well, let's try 14/7. That's essentially 2. Right? It's 14 divided by 2, or 14 divided by 7 equals 2. So we could say 14/7. Let's put that into this for b. 14 plus 5 is equal to 19/7. And is that greater than 2? 7 goes into 19 2 times. And we have 5 left over. So we have 2 and 5/7. Yes, that is greater than 2. So this answer of 9/7 works. B is greater than 9/7. I hope you enjoy. This is now perfect time for you to start working on your homework for Goal 2, and that starts on page 244, or at least the homework that will pertain to this video starts on page 244, so do some of those problems and get yourself a summative assessment done. Thank you.